Thank you, and thank you for showing up. Before I start this talk about learning and teaching, how many of you actually would identify yourselves as teachers in one way or the other? Okay, cool. Thank you. So as you can see on my slide, I sort of describe myself. I put speakers on stage. As Simon says, I am the PC chair of a lot of GOTO conferences, also have been for QCon conferences and YAO conferences, so I put speakers on stage. And then I mess with the heads of students. I started teaching in 1998 at the University, Computer Science in Denmark, and since 2001 I've been teaching in industry as well. So I try to make people think in a different way, so that's why I have them messing with the heads. And the last point is helping developers talk with each other, because what I also do is that I facilitate retrospectives and all sorts of meetings to try to enable people to talk to each other, sometimes about things that are difficult, like if they made a mistake or something like that. So, why would you want to come to this talk? There are 3 learning goals, and I'll go through them first, and then I'll go through them in the end so that you know why you've been sitting here. So the first learning goal, why would you listen? Maybe you want to become an expert. And I suppose that's probably the most valuable thing for you, so we'll just get that rid of right away and then move to the other 2. So there was some brothers, Stuart and Hubert Dreyfus, in 1980. They made a model of skill acquisition. Unfortunately, you can't see the title of my slides. It's supposed to say Dreyfus model of skill acquisition up there. I don't know why it doesn't show, but I have to read it aloud. Imagine it says skill acquisition up there. So how many of you know that Dreyfus model of skill acquisition, how to become an expert? Some of you may have heard it. I think when you see it, you recognize it as something you've seen before. So imagine that you have a new thing that you want to become an expert in. So maybe you buy a book and you read about it. And that's when you are a novice and you know the context-free rules. Then maybe you want to learn a bit more, so you go and watch a presentation at a conference like this, and then you become a beginner. A beginner is the one that can apply some guidelines. If you come to a presentation like this, you'll normally see people talking about their expertise, giving you case studies, showing you guidelines on how to make use of this. So instead of just having the rules and go by them, you learn some guidelines from experienced people. The next step is that you try to apply it on your own. And applying it is a very important part in becoming an expert. So once you've applied it, you become what they say is competent. So when you're competent, you can actually respond to the unexpected. So instead of just being able to follow the rules and follow the guidelines of other people, you start making your own guidelines and you can respond to the unexpected. The next step is that you discuss your experiences. So you can either discuss your experiences in your workplace, with your colleagues, at a conference, during networks or something like this. And once you start discussing your experiences, you learn, you share, and you learn from others. And that's when you become proficient. And when you're proficient, you can unconsciously combine the processes and you can respond to a nuance of situations. But you're still just proficient. So what do you need to do to become an expert? And this is why I'm talking about this Dreyfus skill acquisition. Because once you start teaching or giving presentations about something, that is when you become an expert. That is when you have that intuitive grasp of the whole situation. So once you start teaching something, you'll be faced with a lot of questions from the students or from the audience, and all those questions will make you think about things in a different way. So the software company that I worked for right after my PhD, and actually my old boss is sitting right there, and he's the one who did this to me, so we can point at him while we're saying this. He had that idea that if you wanted to learn something, instead of sending you on a course, they sold the course, and you would be giving the course. Because he had the idea, which I thought was a bit sadist at the moment, that once you teach something, you really learn it. But he was right, and that sort of started me in my quest of anything I want to learn, I want to get into a place where I can teach it. So I want to become proficient so that I can start teaching about it so that I can become an expert. So this is all a bit meta, because right now I'm teaching how to teach computer science at the university. So I'm trying to become an expert by doing that. And that's why I'm giving this talk today. So that was the first of the learning goals that I wanted you to have, how to become an expert. So the second learning goal that I want to share with you today is how to become better at learning yourself. And this, to me, is possibly the most interesting part of this presentation, because this is about the research in how the brain works. How does your brain change when you're learning something? Because I believe that in order to really make use of it, it's better to understand why it works. So I'm going to go through some different things with you. I'm going to go through something called the chunks of information, patterns and automata, learning preferences, and constructivisms. It's all really old research. It's based upon research from the 70s and up to 2010. But even though the research is old, the brain still works sort of the same. And I still make use of it. I started being interested in the research behind teaching and learning 6 years ago. And before that, I had been teaching for 12 years without knowing what I did. I had, of course, made my own what they call theory of practice. So I knew what worked and what didn't work, but it was only when I started being interested in the research behind the brain that I suddenly realized, oh, so that's why this works, and that's why this never works. And one of the big epiphanies for me was that even though people are thinking and learning in a different way than me, they're not necessarily stupid. And since I have been a university professor for many years, I'm sure that my students really appreciated when I suddenly understood that fact, that maybe I should just treat them in a different way. So that's what I'd like to share with you today. And the third learning point, I want to give you an anecdote to entertain a dinner party with. And since I think that that's probably also on the top of your list, I'll take that before you start falling asleep. So this is a picture of a mid-play chess game. This is a chess game between Deep Blue and Kasparov. Some of you might have noticed. This is step 22 out of 37. How many of you had already seen that? Right, a few. Impressive. So this is the first time that a computer won over a human being in chess. So thinking about what makes you an expert, people have been interested in chess players for many years. Because with chess, you can really see a difference between a novice player and an expert player. So they've been very interested in trying to figure out what is it that happens in the brains of experts? Or more, what is it that happens in the brains of novices so that they can become experts? So a lot of research has taken place. And this is one of the more fun ones, I think, or at least the result is a bit fun. So this is a mid-play chessboard, right? So we've sort of taken a snapshot out of the video of the Deep Blue versus Kasparov. And then we've showed it to a number of chess experts, and we gave them 5 seconds each to look at this board. And then we gave them a board with a lot of elements on the side, and they should place the elements in the right places. Then we gave them 5 more seconds to look at the board, and then they had more time to arrange. Each time, all the elements was taken away from the other board, so they had to start from scratch. We did the same with the novices. So the novices had 5 seconds to look at the board, and then they had some time to arrange it. 5 seconds again, and then they had some time to arrange it. Now, my first question to you is, who did best? Who were best at placing the elements on the board after having seen it for 5 seconds? I'm going to ask you in 2 different tempi. So first I'm going to ask you, how many of you think that the novice was better than the expert at doing this? Please raise your hand now. Right? Is that a question that you have, or? Good. And how many of you think that the master or the expert is better than the novice? So you're about 50-50. So what's that based on? Can I ask that question already? So So you said that the master is better than the novice? Because the master sees the patterns in the game. Yeah. Let's look at the result. So, as the man said, the master is significantly better than the novice. The master is on the top here, and the novice is in the bottom. And you can see for each time there's a measuring point. They had 5 more seconds to look at it, and they start off being far away from each other, and of course the novice is catching up, but the novice actually never even reaches the master, because there's something that they just keep messing up. So that was maybe not so surprising. Let's look at another chessboard. So this is a chessboard which is not mid-play. This is actually created by JavaScript's math.random. And then, or it could have been a child that put the elements there, but definitely this is not a mid-play chessboard. We did the same again, 5 seconds each. Now, who thinks that the master is still better than the novice? Who thinks the master is still better? Nobody. Who thinks the novice now is better? A lot of people, right. And you're right. So if we look at it now, the master is not doing very good. The novice is doing exactly the same. You probably can't remember the other graph, but the novice is doing exactly the same as he or she did before, because, well, it doesn't make sense. But the master is really struggling, significantly worse than the novice. And of course, it is because of the patterns that we saw before, because if we look at the difference between an expert and a novice in chess and in anything else, what the expert in chess knows 100,000 of board configurations and their associated rules. So they have some patterns in their head, and they have some automata. So if we look at other researchers about chess players, then the novices think about as many different combinations of changes on the board as the expert does. But the expert only thinks about the good ones. And if we look at the eye movements of people looking at a chessboard, there's also a difference in it. You can actually see that the expert is looking at patterns on the board, while the novice is sort of just going around with his or her eyes, just looking at all the elements one by one. So the good thing about being an expert is that you have these patterns and you have these automata, and you don't have to spend too much time thinking about what the best solution is, because you know already. That's a part of expertise, and also goes with coding, you know that as well. And the reason why the expert did so badly in that mid-play chess game, why was that? Any idea? Yeah. So what he said was it doesn't make any sense to the expert. And that's true. So when the expert looks at a random chessboard, he spends a lot of energy trying to make sense of something that does not make sense. So he confuses himself with trying to recognize things that he can never recognize, or she can never recognize, because it's not part of the patterns in the head. And that's a problem. I'll come back to that later in an example. Because I want to tell you a story also. I want to put this around a story. So I know that you're not all teachers, but I guess that sometimes you get an apprentice in your company, somebody that you have to teach how to work with the system or the systems that you're doing, or work in the way that you do in your company. So you get this apprentice, and you really want to turn that apprentice into an expert. So you figure out what the apprentice should know, and you start telling the apprentice all the things that the apprentice should know. Right? So that's the story I want you to think about. How many of you can relate to that? Yeah, you all know. You get some new people and you need to tell them everything. But I want to do a little experiment with you first. So before I start going into that story, it says now to something completely different up here. You can't see it. And then it says, activity, let us divide the room. Okay, so we can divide the room here. And whatever you do, do not write anything down right now. That's what it says as well. I'm going to show you 10 words. And you shouldn't write them down, because if you do that, you ruin this exercise. So for the people on that side, when you see a word, count the letters and say the number in your head. And for the people on this side, when you see a word, say a related word in your head, but in your head, right? Don't start. I just did this in Australia. Everybody shouted out. They're upside down there. So I go through all the words, and you just do what I ask you to do. You remember that? Okay, good. So, right, thank you. I'll let you know later what this was all about. But just don't think about it right now. Back to the story. So, you talk to the apprentice. It takes all day, and you use numerous examples. But the apprentice still doesn't get it. It's just, when you're talking to him, right, head to head, he'll be nodding and he'll say, yes, I understand all of this, it's working. Yeah, I understand, definitely. And when you're pushing a button, he can push the same button. So it seems as if he understands everything. But at the end of the day, it doesn't work. He doesn't get it. You ask him the day after, the week after, he doesn't get it. He's forgotten everything. It doesn't really work. So what's happening? What's happening in his brain that makes it not work? So I've got a picture here which shows the brain memory. It also shows why I went into computer science instead of creative stuff. So I put some labels on it. You can't see it. This is the nose up there. It should give you sort of a viewpoint of it's a head seen from above, and the nose is up there, right? And then we've got something called the long-term memory in the back of the head, and we got the working memory at the front of the head. So according to George Miller, that some of you may have known about, 1956, he made this theory about the working memory and the long-term memory. And the working memory is the memory that you can work with right now. Whenever I see a chair, I walk into a table, I hear somebody say something, I use the elements in my working memory to take these things into account and try to figure out what I should do next. So whenever I'm learning something, I hear a new concept, I see a new thing on the screen, I hear somebody else doing something, try something out with my hands, it takes up one of the elements in the working memory. So when he came up with that theory, he thought that in this working memory you could have 7 plus minus 2 elements at a time. Unfortunately, recent research shows that it's only 4 elements. And I don't know whether we're becoming more stupid with the iPhones and stuff, or whether it's always been like that, but anyway, you have to think about it as 4 little elements, 4 bricks that you can use when you're learning something. And you could easily, I suspect, understand that if you only have 4 different elements, like 4 rows for concepts, it's really difficult to learn complicated things. You can only learn things that contain 4 elements. And a lot of the things that we do in IT contain a lot more than 4 elements. And that's where the long-term memory comes to rescue, because let's see how it's working in the brain. So whenever you hear something, you try to learn something, you're working with this working memory, and you're trying to make sense between the elements in the working memory. So the pink stripes here is where I try to make sense. I try to make a picture of all the different things that I'm trying to understand right now. And then sometimes one of the things that I have in my working memory is related to something in my long-term memory. And when it's related to something in my long-term memory, I can do what they call decoding something into my working memory. So maybe I've learned something previously that is associated to something new I've learned, and then I can take this from my long-term memory and decode it into my working memory. So I can make use of something which is much more complicated than 4 elements, because I can take something which is much more complicated and make it be represented by 1 element in my working memory. And in that way, I can actually, little by little, build an understanding of something very complex out of the 4 elements I have together with the long-term memory. So let's imagine that we took in some input from the outside, we decoded something from our long-term memory, and now we're working with it in the working memory, and we also have this still in our long-term memory. So once we have figured out how these things go together with the new things, what do we do then? Well, we do the other way around, and we say now we encode the patterns into the long-term memory. So we take something into the working memory, we might decode something out from the long-term memory, we work with it, we make a new pattern, and we take that pattern, we put it back in our long-term memory. And whenever we've done that, we've built a little bit more on the things that we have in our brain. And we use that actually in IT. So let me make a reference to design patterns. When you learned the visitor design pattern, did you just learn it like this? Or did it take you a few times, a few implementations in order to learn it? I could definitely say that for myself, learning the visitor pattern, it was not like the singleton pattern or the observer pattern or the strategy. The visitor pattern, that took time. I thought I understood it when I had it explained, but I lost it again. I had it explained, I lost it again. I had to implement it several times before it stuck into my long-term memory. And that's because, as you can see, it's simply too big to be in the working memory. It sort of spills out of the edges. So what you do instead is that you say, well, once I've learned the visitor design pattern, it will always be there in my long-term memory, and whenever I want to make use of it, I can take it out into my working memory, and one of the 4 elements will just be a reference to this whole pattern. So when I think about visitor as one concept in my working memory, is actually a reference to a much more complicated thing inside my brain. So in that way, I can work with things that are very complicated. When you think about patterns in your workplace, I'm sure that everywhere that you work, you have some patterns. Some of you might have written them down, some of them not. I always try to tell people to write these patterns down, because once you have them in writing, once you think about how you can cut them out, how you can explain them, it's much easier for a novice to actually encode that into their long-term memory. Because you already said these are the things that belong together. And some companies say that they don't use patterns because it's silly. For instance, I have a good friend in Google, and he said that design pattern, we don't really use it. Well, of course we use visitor, but all the others, we don't care about them. And we don't have patterns in our workplace, but actually they do. I talked to him, and I tried to make him explain to me, so what do you do, for instance, it's all about performance where he's working, and what do you do then? Don't you have any patterns? And he said, well, actually now that you mention it, we do have something. It doesn't have a name. But it's about when we have a bottleneck in our code. We have something which makes our code really slow, but we don't know exactly where it is. We don't know whether it's in one of communications with our database, or whether it's the algorithm, or whether it's a communication with a server, or where it is. So what they would normally do was to try to remove all the things that they thought were obstacles, and then measure it again, and remove this obstacle, and measure it again. And once they'd find gold, and they would have removed the obstacle that they needed to remove. But what they found out instead was that much more efficient for them was to do something that we then started calling the double bottleneck. So instead of trying to remove the obstacle, they just doubled it. So if they thought that maybe it was this algorithm, they would run this algorithm twice. If they thought that it was a communication with this server, they would have the communication with the server twice. And then they could measure it, and if it exploded, they knew that they'd found the right place. And the smart thing for them was that it's much easier just to double something than to try to remove it and solve it. So by doubling it, which you can do pretty easily, you can quickly, but of course a bit dirty, find out where the bottleneck is. So that's why they call it the double bottleneck. So they actually do have patterns, and you probably have patterns as well. Maybe you hadn't thought about them, but if you're training novices, it's a good idea to try to think about it, and giving them a name makes it much more easy to use it as one of the 4 elements. Because otherwise it'll be, oh, you know that thing where we try to double the thing that makes it slow? It's much easier to have a name. It's much easier to learn this. Yeah, so I have this question, what are the patterns in your workplace? Does anybody have a pattern they'd like to share? Mm-hmm. Mm-hmm.
We have a web server provisioning pattern. It's kind of fuzzy around the edges, but we have a general idea of what it should look like. So we've written it down on a wiki, and you can reference that and pretty much get everything in place that we need to in one go.
Yeah, so you have something that you've written down in a wiki, and you can use it to communicate with new people in the company. And does it work to have that? Oh, good, thank you. That was exactly, I'll give you the beer afterwards. That's what I needed to hear. But what if the apprentice still doesn't get it? What if this is not enough with the patterns and the automata? What if the apprentice still, can't remember this, I can't work with this. What else could be wrong? Then I'll give you a teaching anecdote from the beginning of the century. So in 2001, when I first was sent out to teach in the industry, I thought that object orientation was the only thing in the world, and I was sent out to teach some people who had another sort of upbringing. It was like 45-year-old men, which I thought at that time was really old, which I think today is really young. And they had been working with like functional programming, other paradigms for 20-odd years. And I was sent out as a very young girl to teach them about object orientation and Java. It was an uphill battle. I won't talk about the details about this, but I'll just talk about what I learned when it comes to teaching and learning. So my introduction to them to object orientation was, well, you have this picture of the real world, and then you make this nice design like rounded in UML with all the classes and the relationships between the classes, and then you make this really beautiful Java code. So that's what you should do, and it should be easy. Unfortunately, it didn't really work that way. So I gave this assignment to my students in the room, and I said, so this is a real world problem. Please make an object-oriented design and some Java code based on this. And I had expected them to do something pretty like this, that it would be nice Java code with things in classes and small encapsulated things. But what happened was this terrible thing came out of their keyboards. They made some really, really ugly Java code. They were still using the Java language, but they were misusing it in terrible ways, and it didn't look good at all. I didn't understand what happened. And I was even told, I talked to some of the people at the company, and they said, but these are our most intelligent people. These are really good programmers. And that is why we spend money on trying to teach them the newest things. So they're not stupid. I thought they were stupid, because they wouldn't learn. I would jump up and down, and I would tell them all the beautiful things about object orientation, but they just didn't get it. And they were supposed to be intelligent. Luckily, I was teaching this course 8 times in the same company, so I started noticing what went wrong. And you probably all figured it out. Because what happened was that in their procedural brain, whenever they saw a problem like this, the patterns and the automata in their long-term memory would solve the problem in a split second without them even thinking consciously about it. They would solve the problem in a procedural way. And then I would try to force them into putting this into Java code. But of course, since they had all these patterns in automation in their head, it seemed like they could only make shitty Java code. But it was only when I suddenly started noticing that the patterns in the Java code was recognizable to me as something completely different than it should have been, I suddenly realized, wait a minute. So what I have to do is to try to figure out how to make them think like I think. Because in my object-oriented brain, the way that I worked was that whenever I saw a real-life example, I would instantly create an object-oriented class diagram from it as a response to this. So I needed to figure out how to make them think in that way. So in the beginning, after I noticed that, the first course I said to them, now please forget everything you know about programming and let's start from scratch. That didn't work. It's not that easy. You can't just say that to people. But the problem is that I had to break down the structures in their brain in order to make them get some new structures. And breaking things down in the brain is actually really, really painful, which is why it's difficult for people to learn, because there's sort of a little bit of pain that you're not conscious about. But whenever you're changing the wiring in your brain, the brain don't want to do it. I call it pain. You could call it use of energy, something else. But you're not really interested in changing. The brain really likes to just, when it's got a world picture, let's stick to this world picture. You see that in politics as well, I suppose. At least in Denmark. I don't know about America. So, yeah, what I found out was in order to try to change this, I had to take them on another route. So instead of saying, go directly from this and to code, I had to figure out how to cut that into pieces. So I said, okay, now you've got the real world domain. Now the next step is to try and explain this. At that time it was in use cases. Try to explain this in use cases. Then trying to explain it in analysis diagrams. I never thought analysis diagrams was worth anything, but it turned out they're very good for trying to take people at another route that they would normally do, because they couldn't use their patterns in Automata to make analysis diagrams. So I took them that sort of detour around it through analysis documents, through design documents, through test cases, and then to the code. And that worked. Because I took them out of that automation of the patterns in Automata that make them solve things right away and figure out there's another way to get them here. So that is one way of thinking about it. And we actually have a Danish philosopher, Søren Kierkegaard, who said once, and I'll read it aloud because your Danish is not that good, at man, når det i sandhed skal lykkes en at føre et menneske hen til et bestemt sted, først og fremmest må passe på at finde ham der, hvor han er, og begynde der. That makes sense, right? Yeah, to the two Danes. So I try to compile it, but it's not quite as beautiful as it is in Danish. But that when you want to succeed in bringing a person to a certain place, must start by finding out where he is from the start. So what I'm trying to say here, and what Søren Kierkegaard was trying to say here, is that in order to take somebody from some place and to the other, it's very important you know where he is before you start teaching. So one of the things is that when you start teaching, always try to figure out what do people know already. What is in their heads that they are struggling with. If you're teaching a course at university, you will know the prerequisites for that course. So you'll know what courses they've taken. But we've seen in the physics teaching at universities that people come up with their childish understanding of physics that are wrong. You probably all have had that childish understanding of something that you know to be true, but real theoretical physics show you that it actually is not true. And the interesting thing is that the brain does not have a problem with that. As long as it can as long as it can stick to where it was already, it doesn't matter. Let's take a very simple example. So we have a student here coming to university thinking the Earth is flat. All in his life is sort of based on the fact that the Earth is flat. He's taking a course which is showing him that the Earth is round. So his whole life should change based on the fact that the Earth is round instead of flat. He understands everything in the course. He's nodding, he's doing the assignments, everything works until the exam. Which is the weird thing where we sometimes realize, especially at an oral exam, that you ask a student a question and the student answers, and then you ask the student another question and the answer is completely contradictory to the first answer. And then you understand that this poor student has two different models in their head of how the world works. And of course, the world being round and flat is a very stereotyped, very simplistic one. But I've definitely seen students having two understandings in their head. And that's the other reason why it's so important to figure out where they are. Because you need to figure out what are their misunderstandings and try to sort of destroy them before you start giving them the right information. You have to destroy the fact that the Earth is flat before you can teach them for real that the Earth is round. Because otherwise they'll have patterns in Automata that are contradictory to each other, and that will make them seem very stupid and confused. So it is extremely important to figure out where people are. But what if the apprentice still doesn't get it? What if it's still not working, even though you're trying with patterns and you're trying to figure out where they are and you're trying to figure out changing the automation? What if the apprentice still doesn't get it? What else could be wrong? Well, then we've got something like learning preferences. We've got the Felder-Silverman model I'm going to talk about. There are a number of other models. You can choose whatever you want, but I like this. I think it's very interesting. So in the Felder-Silverman model about learning preferences, there's some spectrums. You could be either a global learner or a sequential learner. And if you're a global learner, you absorb large jumps of material, and you do it almost randomly, and then you don't really understand the details, and suddenly you see the big picture of everything. But if you're a sequential learner, you like to take in little bits of information. If you're shown the big picture first, you do not want to see it. It doesn't make any sense to you. You think it's too abstract. You think it's silly to look at the whole picture. But you want to see the little details work first, and then you can build your own big picture. And the interesting thing about this is that people have different learning preferences themselves. And what normally works when you're doing something is to show people the way that you learned it yourself. If you try to remember how I learned this or how I learned that, maybe you can use that in your teaching. But you cannot use that without thinking that people have different learning preferences. Me, myself, for instance, I'm a very extreme global learner. I try to see the big picture instantly, and then the details I'm not so interested in. They'll come whenever I need them. But the big picture is very important for me. So that's why when I was teaching, I would always try to make the big picture first and then give all the details later on, because I thought they were not as important. And that would piss people off. Because the sequential learners, they were not interested in seeing the big picture. They thought it was just a waste of time to see the big picture. They were not interested in anything apart from all the details. So thinking about that when you're teaching somebody is trying to figure out, how do they actually think? Do they like to see the big picture, or do they like to see the little things? And if you cannot figure that out, then try a little bit of both. Say, well, I'll show you the big picture for my own sake, because it'll make it easier for me to teach along the way. Then I can point to different things in the big picture. And then you can take the details one after one. Another learning preference spectre is the active versus the reflective learners. So some people are active learners, which means that unless they can discuss things or they can do things, they cannot learn anything. And the reflective learners are on the other end of the spectre. They need to reflect about things. They need some time on their own to think about it before they can learn it. And if you look at presentations at conferences or lectures at universities, for instance, they don't cater for neither of those. Because the people who need reflection, they don't get reflection because people constantly speak to them. So they can't reflect. There are no breaks for them to sort of take this in before a new thing starts. And the active learners, they need to discuss, they need to be part of it. They need to do something to learn it. So things like this doesn't really work for anybody on either side of the spectrum unless you try to make them think about things, which is why I have these things where I want you to think about things, because I want you to give a break to reflect and or to be actively thinking about your own experience in relation to this. So back to the activity. Now, if you've got paper, then please write as many words from the list that you remember, or a phone or something like that. I'll give you a few minutes. Don't talk to each other, just write them down. Somebody's still writing? Thirty more seconds. Right. Now I'll give you the list of words, and then count how many you could actually remember. And if you did write it down, it might seem like you could remember all of them, but try to count as right as you can how many you can remember. Right, and then keep that number in your head. So how many did you actually remember? If you remembered at least one word, put your hand in the air. Okay, if you remembered 2 words, keep your hand in the air. If you remembered 3, keep your hand in the air. If you remembered 4, 5, 6. Okay, let's back to 5. Otherwise this won't work. Thank you. Right. So look, keep your hands up where you were. 5 words. Look at this side and look at that side. What is the difference? We got 2 out here who can remember, and we got 6, 7 over here who can remember 5 words. You could take your arms down now. So what happened? What did you do over here? You counted the number of letters in the word, and 2 of you remembered 5 words. And what happened over here? You made a relation to the word, and 7 of you remembered. And you are approximately the same number of people. There might even be a bit more over here. So what happened? What's the difference? Anybody? Association. Yeah? Exactly. So you found something that your related words would always be something from your long-term memory, otherwise it wouldn't be there because you had everything else, and you just had a number which didn't make an association to anything. And that leads me to, what if the apprentice still doesn't get it, right? So this is a brain with content. So here I've tried to picture, this is a brain and you have a content, this is what you know in your long-term memory. These are the patterns and the automata that you have. And then you have some new events and you process these events and you try to encode them into your long-term memory, right? And that's what's happening when you're spending a day with a novice and they're nodding and they're remembering what you said in the morning, maybe if you're lucky, and then the next day it's gone. Because the encoding failed. And that's because of the construction that didn't take place in the right way. There was a researcher called Jean Piaget who figured out that the way that you learn is actually to construct learning with something that you already have. So unless you figure out what's in their brains already and associate that with the new learning, the construction fails. And there's an interesting thing here about teaching, is that we like to have anecdotes, we like to give examples, to make people think about the things that they already know. And some people have been wondering why women in mathematics and computer science maybe didn't do so well at university in Denmark. But if you look at all the examples and the anecdotes that was used in the teaching, it was about beer and football and fast cars and things like that. And I know that there are women interested in beer, football, and fast cars. I know I'm definitely interested in beer, which may have been because, maybe that's why I stayed at university. But if you're not trying to relate what you're teaching to something they already have in the head, like the rules of football, if you relate your teaching to the rules of football and that is not already in their head, it just disappears. It doesn't work. You need to figure out what's in their head so that you can make it sting to the things that are already there, stick to the things that are already there, so that it stays, because otherwise you're just going to lose it. Now the last thing that I want to talk about is that it's not enough to talk about the content. It's not enough to know what you are talking about and how you should talk about it if people do not want to listen to you. So let's see how much you remember of your undergrad maths. What does it say here? Anybody? Logos? Logos, pathos, ethos, right? Logos, pathos, ethos. And this is Aristotle's modes of persuasion. And persuasion is something you can also use when you're teaching or giving presentations. And let's sort of look at these in detail. Logos, what you're saying. It is, of course, very important to know what you're talking about. Otherwise, it'll be a bit embarrassing when people ask questions. I mean, you can learn just so much by heart, but you can't. It's not a good idea not to know what you're talking about. So logos is that you know what you're talking about. Pathos is how excited you are, how much passion you show on stage, how enthusiastic you are about what you're talking about. And that, of course, can be faked if you want to, as we can see online. And ethos, who do they think you are? And that could be if you are very respected in the field, then you have a lot of ethos already. And if you're a university professor, you initially have a lot of ethos. You don't have to prove anything, but you're already up here and other people are down there. Somebody who's got all three of these is Mr. Obama here. He's really, really good at giving presentations. I mean, no matter what you think about his politics, I don't think many people would disagree that he's really good at giving presentations, because he's got the logos. I believe that he knows what he's talking about. He's definitely got pathos, and he's definitely got ethos. He's got all three of them. Unfortunately, we cannot all be Barack Obama, right? So we have to make do with a little less. But it turns out that 2 out of 3, as in anything else in life, ain't that bad. So if you know what you're talking about, and you're really enthusiastic about what you're talking about, it is okay that people don't know who you are. This is me talking about teaching and learning from stage right now. I know what I'm talking about, I'm really passionate about it, but you don't really know who I am, and it doesn't really matter, because I've got 2 out of 3, right? So we see that everywhere. When we put novices on stage, if they know what they're talking about and they're passionate, that's fine. Ethos can come later. Or you can prove the ethos during the presentation. Of course, if we have somebody who's really famous and they know what they're talking about, it doesn't really matter how enthusiastic they are. I mean, it would be nice if they were great on stage. But if it's like James Gosling, he knows what he's talking about and everybody knows him, it doesn't really matter if he's boring, which he is. And it doesn't really matter, because we want to see him anyway. And the interesting thing is that actually, if you're really excited about something and people really want to hear you speak, it doesn't really matter that you don't know what you're talking about. And I suppose that some of you have known somebody to do that, right? That sometimes, if you really want to see them talk and they're passionate, they don't really know what they're talking about, but it's still good. So whenever you're trying to teach somebody something or give a presentation, please think about these 3. Where am I on this? Where am I on logos? Where am I on pathos? And where am I on ethos? And if you're low on one of them, push up the other 2, or try to work on the last one, okay? So I'm wrapping up now. What did you listen to? I have these 3 learning goals: how to become an expert, how to improve your own learning, and an anecdote to entertain a dinner party with. And I think that we got all 3 in a row. So thank you for your time. How am I on time?
That's 2 minutes.
2 minutes, right.
There's no questions submitted, so.
Does anyone have a question?
Over there.
Okay.
A lot of online learning relies very heavily on testing and assessment as part of the process. Could you comment on how that fits in terms of the frameworks you've described?
Yeah, so I think that all the testing is definitely a good thing to reinforce the patterns and the automations that you have. That is the way that I like testing. So testing can be used in many ways. It can be used to make you aware of what is expected from you. So I know that if I fail this test, I have not learned what was expected from me. It can also be that the teacher will know, well, maybe I didn't do this well enough, I need to do something differently. But testing is definitely also that you can use to reinforce the patterns and the automation. So what I do when I'm teaching at university, a big crowd of maybe 200 people, I make 10 tests during a 3-hour lecture. And I do it with little clickers. So I have maybe some code snippets up there, and I say, you've got these 3 different ways that this could give an output. Is it this output, or this output? And then they press the clicker 1, 2, or 3, and I see how many of them say 1, say 2, say 3. So what I get out of this is that I get an understanding of what they know right now and what they don't know. So maybe I need another example. Maybe I should skip it. Maybe I should do something completely different. But also they will know, well, whenever there's a pause in the lecture, they can think about this code snippet and the output of it. So it reinforces the things that I already said. So I think that the testing is a good thing for reinforcement.
So if you're interacting with a larger group of people,
and you kind of said there's people that have different learning patterns and they fall into those different categories. You mentioned one strategy for dealing with that, which is kind of do the global and the sequential. Are there other tips like that that you've found that have worked over time when kind of a one-way communication or with a larger group?
Yeah, definitely. So communicating with a larger group is not possible. I can speak to them, but I cannot really communicate with them. So, and I really I feel it's important to communicate for people to learn something. So what I do instead in situations like these, I try to make peer learning or peer discussion. So I try to make people talk to each other pair to pair, or sometimes in groups, and that also enables them actually to ask me questions in a big group, because if they know that 3 other people are struggling with the same, it seems more okay to ask the question. So if I'm with 200 people and I say, are there any questions? There won't be. Well, there'll be that geek up front row who's talking about, he'll have a question about something completely unrelated, but otherwise people will be totally quiet. So what I do there is that I try to make them talk to each other so that they know that other people are struggling with the same. And that's also what I do with the clickers, is that they can see, wow, okay, 75% of this room got this wrong. I'm not the only one who's being stupid, so I can ask questions to the teacher, but also, and not less important, to all my co-students. Yeah.
Thank you, Aino. We're out of time. So please thank Aino.
Thank you.